discuss we'll discuss the answers on the test. Can everyone take out your pen?
Robert. Really
Okay, so can everyone take out the test paper? Okay, so I know some of you may not be very satisfied with the result of their life. Yeah, and we'll discuss the answers. Okay, so some of you did very good job for the multiple choice and you got it all correct. Some of the students. Yeah, all correct. Multiple choice question number 1. The answer should be dog. Okay, the first one. Yeah, take out your notebook now. Write on the okay. Yeah, you may write on the test paper. Okay, but make sure you keep it. Okay, yourself. Okay, you will be using that to keep revision. So the answer to the first question is D. Yeah, because cooperative plus. Write this down if you got the wrong answer. Cooperative plus give a bluish green flame. Right. That's why I congratulate some of you. Got all the multiple choice correct. Yeah, you deserve an applause. Yeah, so and in the meantime you can just listen if you get it all correct. But for the rest of the students who may have got some of the questions wrong, write down why this is incorrect. The other options. So Na plus, K plus. The colors are lilac, yellow or golden yellow, brick red, and bluish green. Okay? Yeah, so the answer is dog for question 1. Because it is the only one that produces a correct color. Okay? So what about question 2? Well, if you're unsure about the other options, you can use the method of elimination. Okay, so here's the trick. Okay, that you can use in the exam. If you're unsure which is the correct answer, just eliminate all the wrong answers. There is something incorrect in statement A, C, and D. Okay, for question 2, the answer is B. Okay, that's because A has something incorrect, C has something incorrect, and D has something incorrect. So can you tell me what is wrong about statement A? What?
not density.
Not density. What is the physical point of difference there with?
Boiling and
Boiling point. Boiling point. Yeah, so can you cross out the word density? We don't separate it based on the difference in density, but instead, boiling point. Yeah. Use this technique called method of elimination. If you aren't entirely sure, it will be pretty useful at times. So method of yes? Right. Yeah. I wrote down some numbers there because I want to figure out how many marks you lose. Okay, like the picture of you lose. So don't worry, I will just subtract it from the total mark. What about C? What is wrong with statement C?
It's not negative 80 degrees.
It is actually negative 80, but we remove. Yeah, we should cross out oxygen and water. Very good. Yeah, so close. Okay, so it is not oxygen, but water. So correct that. So water. And finally, what is wrong with statement D? Negative 200 degree. Okay, so we cross out negative 100 degree. We replace it with negative 200. So what we need to remember for the fractional distillation of air, a few key points. We will first cool air down from 25 degree to negative 80 degree. And then to negative 200 degree. And then we slowly bring it back up. Okay, negative 196, negative 186, negative 183. So you see the temperature changes like progressively. And in the first stage, we remove something called carbon dioxide and water. What do you call the solid state of carbon dioxide?
Dry ice.
Dry ice. Yeah. At this point, when you cool it down to negative 80 degrees, these two will solidify. And as they become solid, you remove them. Because you are trying to collect the three main gases in air. What are the gases that you can collect in here? After you remove carbon dioxide, what are the three main gases left? Nitrogen, oxygen, argon. Yeah, okay. And which is which? Yeah, because I also do not remember the boiling point, and neither should you remember the boiling point. So we look up the boiling point of components in air. So we have, just a second. Right, we have, this is in Kelvin. This is not the usual boiling point. Anyway, so we have in here. So it says it is 90.6 Kelvin. Okay, which means it's 108. Okay, I'll just refer to this thing in here. So we have this in here. So nitrogen. The boiling point is negative 196. You don't have to remember that, but you can put down the first one to boil is nitrogen. Then the next one that boils off is so yeah, that's fine. Let's know from here. We have oxygen. Oxygen has the boiling point of negative 183. So this is negative 183. So this is oxygen. That means the remaining one should be argon then. Okay, so the remaining one. So we have argon here. Argon is negative 186. So you have argon. So remember the order. The order at which the gases pour off is N followed by A followed by O. Like now. That's now. Okay, so this is the order in which the gases boil off. Okay? And if you can't remember the number, it's okay, because I can't remember it. Okay, don't worry. So we can use the this method to cross our answer. What about question 3? What is the meaning of an element and compound? What is the meaning of element? Is only one word. Type of atom. Compounds contain two or more types of atoms. Chemically bonded. Right. So let's put it down. For question 3, the correct answer is D. Most of you get this right. Okay. I'm impressed. Okay. So just put down, but still you need to know the definition. So yeah. In the first term exam, maybe I'll give you a written question, okay, on the definition, so make sure you also know. So contains only one type of atom. And compounds contain two or more, not necessarily two, but two or more types of atoms. The keyword is chemically bonded. Right, so that means things like this will be an element. So this is an element. This would also be an element, you see. Okay, so this will be an element. What are compounds? Things like this could be a compound. See? Okay, so things like this. Things like this can also be compound, as long as there are two or more types of atoms chemically bonded. Remember, I compare chemical bond to like glue. Okay, if you see things stuck together and they are not of the same type, it is a compound. Even when you see things stuck together, if they are of the same type of atom, we don't call it compound. Okay, so whether there is a bond or not, that is a secondary requirement. The most important requirement is how many types of atoms there is. If there are two or more types, like you see in here, they certainly look different. You see the black dots and the white dots. This is a compound, and so is this. This is not to be confused with mixture. So mixture contains two or more elements or compounds physically mixed. Underline the phrase physically mixed. By physically mixing things, yeah, you are not bonding them together. So you see, for example, if I have this, and if I have this, okay, what do we call this? We call this a mixture because they are not connected directly in any way, right? You see, okay, these two, they are not stuck together. Okay, those are just very weak forces. So this is a mixture. Okay, we can also add things like this. So this is also a mixture, you see. cannot bond together. So the answer is stop. And for question number 4, oh, this part, this question was a disaster. Okay, yeah, many of you got it wrong. Okay, so let's use method of elimination. What is wrong about statement A, C, and D? For question 4, the answer is void. What is wrong about statement A, C, and D? What is nitrogen for? Does it support burning? What is the gas that supports burning?
Oxygen.
Oxygen. Do you remember learning about the fire triangle in Form 3? Yeah, so maybe write down for statement A, C, and D what is wrong. It is not nitrogen, it's oxygen that supports burning. Another important fact you should know, if oxygen supports burning, what suppresses burning? Carbon dioxide, which is why we use it in something where we don't have in this room, fire extinguisher. Yeah, so it suppresses suppresses burning, which is why we can also answer question 7 right now. Look at question 7. Many of you also got this wrong, maybe because of this the same concept. Carbon dioxide, instead of supporting a flame, it will take out the flame. It will put out the flame. So the answer to question 7 should be stop. Okay, so we can answer 2 questions for us. So what's wrong with statement C in question 4? What is used to feel like argon? Yeah, that's because argon, is it a very stable or very unstable gas?
Stable.
Very stable. So you can write down because it's very stable, it won't cause the bulb, or the fuse to burn out. Yeah, you know the thing inside the light bulb? This is like the fuse. If it is oxygen that is in here, the fuse will pop, it will just burn. Okay, but because this is argon, yeah, the fuse will not burn. So the fuse will not burn. Okay, finally for D. Well, if you don't know the boiling point of oxygen, it's very difficult to eliminate this, okay? But you remember from on top, what is the boiling point of oxygen? It's negative 183. That's not the boiling point of nitrogen, okay? So the boiling point of oxygen is negative 183, not nitrogen.
So
What? Yes.
will you upload the notes on Google Classroom?
Oh, I forgot again. Maybe, yeah, I'll upload it. I forgot last time, right? Yeah, so I'll upload it. Okay, I'll upload it. Alright, okay. But then, what about question 5? For question 5, like I think most of you get it right. Okay, so the keyword is, you see, salt from a mixture of sand and seawater. So if you have sand and seawater, what are the 3 things present in sand and seawater? Sand,
salt.
water, and salt. The term seawater, you can break it down further. It means salt plus water. But out of these 3 things, let me ask you something. What do you call the things that make up a solution? What plus what equals a
Solvent
solution?
and solvent.
Solid and solvent forms a solution. So right now this is the equation. Solid and solvent form a solution, which is related to the long question that was a disaster. And I think only one didn't start the last question right. Only one, the last one. This was a disaster, okay? Yeah, but don't worry, I'll explain. Okay, so you have, put this down, solid plus solvent giving a solution. For this equation to work, the solid has to be soluble. So it must be soluble in the solvent. So must be soluble. But when you look at this question, sand, salt, and water, which of these 3 things is the solid?
Water.
Solid.
Sand.
Solid is something that can dissolve.
Salt.
Yeah, so it's salt. Okay, so can you put down solvent under water? This is our solvent. And salt will be our solid. So this is our solid. And what should we really understand? It is an insoluble substance. You know when you know this for a fact, sand will not dissolve in water. I mean, if it dissolves in water, there will be nothing on the beach. Okay, it is not solved in water. So that means in this mixture, you will really see just 2 things. You will see the sand and also some salt distributed in water. So how are you going to separate the solid portion from the liquid portion. So you see this is the liquid part, and this is the solid part. What is the name of that technique?
Filterizing.
We cannot use evaporation. If you evaporate the water away, you know the salt will remain. Okay, yeah, write down why evaporation is not an option here. Okay, when you do evaporation, yeah, only water will leave. The salt and sand will remain. That means you will end up getting this mixture. Yeah, of sand and a bit of salt inside. Do you get pure salt in this case?
No.
Do you get pure salt in this case? No, because doing evaporation will only remove water. Only water is removed, and you still end up getting something pretty mixed, pretty bad. So evaporation is not good for this particular case. We do filtration first, yes. After we filter things off, remember what you call the solid that remain on the funnel and the filter paper? We call that the residue. That's the residue. So write down. Residue is the general name for the solid that remain on the filter paper. What do you call the liquid portion that comes out? It's out at the F. Filtrate. Filtrate. Okay, so this is filtrate with bits of salt mixed in it, which means it is still not very, yeah, it's semi-separated. Okay, yeah, at least we have separated the sand from it. Okay, so this is the liquid part. So this liquid part is impure. So we do one more step, is to use either evaporation or crystallization. Okay, we do this on, let me be clear. So we do this on the filtrate part only, not on the residue. Once the residue is out, you throw it away, you discard it. Then you either do evaporation or crystallization. But because there is no option here for evaporation, so you cannot take evaporation. But evaporation is actually possible. Okay?
To make crystal.
To separate the filtrate back into water and salt. So you have the salt left, right?
Yes.
And the water will be gone. You know you won't stop until you get a pure substance. That's why we do separation. What good does it do if you cannot separate things into the purest form? Right? So if you are good with just impure substance, then you don't need to do separation at all. Because this is impure. You need to keep separating things until finally they are pure. You see, you only have the yellow salt left, right? Yeah, now you can finally stop. What about crystallization? When you do crystallization, we need to remove enough water so that at the end, beautiful crystals. Okay, crystals are also known as hydrated salt. So hydrated salt means crystal. So AKA, also known as crystals, will form. Okay, and that's because of water evaporation. Okay, right. So the answer for question 5 is dot. Dot. So we equal dot. So here 5D. 5D. We need to do evaporation. We need to do filtration first. Then we need to do crystallization next. So write down step 1, step 2. Yeah. So step 1, step 2. Okay. Question 6 is also did poorly. Okay. Also did poorly. Okay, by the student. So which does not produce carbon dioxide? What's the formula of quicklime? I'm surprised many of you students do not know what quicklime is despite doing the revision before the test. Now can you tell me once again, what's the chemical name of quicklime?
Calcium oxide.
Calcium oxide. So put that down. Okay, especially for those of you, CaO, yeah. Question 6 now. The answer to question 6 is A. So 6A. That's because when you add water to calcium oxide, what forms instead?
Calcium hydroxide.
Calcium hydroxide. Yeah, calcium oxide plus water forms calcium hydroxide. Carbon dioxide is not any of the products. Okay, so calcium hydroxide. Okay, so this is definitely A then. For B, what do you know about clamshells? What is the chemical present in clamshells that will eventually make their way into the mineral called limestone?
Calcium carbonate.
Calcium carbonate. Okay, just know that clamshell, snail shell, crab shell, string shell, they all have one thing in common. they contain calcium carbonate. When these organisms die, they are crushed, okay, by the tectonic plate movement, and they turn into limestone, which is calcium carbonate. So put down a few things that are related to calcium carbonate. Limestone. What are the other two minerals?
CaCO.
One starts with the M, one starts with the C. Marble. Marble, okay, if marble, the rock, okay, and then chalk. Yeah, if you have something made out of marble at home, okay, don't put any acid on it. Don't use any cleaning agent with acid on it because acid tends to dissolve the marble. Okay, I know this is a rock, but this is not a rock that can withstand, okay, the acid action. So calcium carbonate, when you add acid to it, it will turn into salt plus carbon dioxide plus water. Yeah, plus salt plus carbon dioxide plus water. So there is carbon dioxide formed. Oh, what about C? So C, you remember my analogy. Remember that marriage analogy? Where is lead and carbon? What are the relative positions on the metal reactivity? Which is higher? Which is more reactive, lead or carbon?
Carbon.
Yes, carbon. Okay, so if you don't remember where or when we mentioned that, you can refer back to which page? This page. So do you remember this analogy? So this is a marriage analogy. So these two people, they are in a relationship. Okay, the marriage is some type of form. There's now a third person. Okay, they're having an affair. Okay, this third person, in order to check out this, the original person in the relationship, she has to be more reactive, more attractive than this preceding person. And when you look at the order, look at where carbon and lead are. Carbon is above lead, which means carbon is more reactive than lead, or in our analogy, more attractive than lead. So oxygen will want to go near carbon, water wants to go near lead. Now we can write anything. Oh, do you remember how to remember the order?
Yes.
It's same. Please stop calling me. Please stop calling me a cute Sierra. I like her called smart gold. Yeah, that's very good. I think I did.
Yes.
Yeah, so just remember that. Yeah, one way or the other, you need to remember that. Okay, so put this down. For C, write me an equation. Lead oxide plus carbon. Yeah, remember carbon. So oxygen, you can think of oxygen as like this man in a relationship. And this is lead, the less attractive woman. Okay, yeah, the less attractive woman. And carbon as the, more attractive woman. Okay, like that. So what will happen next? She will take the place of lead. So can you complete the equation on the right? Lead
Carbon.
plus,
Carbon oxide.
yeah, so you may have learned this in science or biology. There's a gas called carbon dioxide, okay? So you have now the oxygen, like spending some time with this lady, okay? And this poor lady is getting out of the relationship. So you have lead. So yeah, this is how you know there's carbon dioxide produced, okay? Therefore, C should not be the answer. Finally, what do you call the reaction that describes the heating of marble? We call it thermal decomposition. Okay, nobody completes my sentence. Okay, but you remember this in here. Where is the decomposition? Yeah, heat decomposition means thermal decomposition. So put that down. Thermal. Okay, when you see something breaking down as a result of you heating it, we call it thermal decomposition. Okay, so what would calcium carbonate decompose into?
Oxide and carbon dioxide.
Oxide, calcium oxide, and carbon dioxide. So this is therefore not the answer because it will also produce carbon dioxide. You see? Okay, so let me add this back to your notebook here. Okay, so you have D. When you heat limestone, okay, so limestone is again calcium carbonate. Yeah, so when we heat it, it will turn back into calcium oxide and carbon dioxide. Because carbon dioxide is formed, we cannot pick this as the answer. Okay? this question is asking you which will not produce carbon dioxide, so A is this. Okay, you don't see any carbon dioxide on chloride. And for question 7, I will just give it. Because hydrogen, what will happen when you put a burning flame near hydrogen?
Popping sound.
Yeah, you will hear a very loud pop. You should have all have done an experiment on this, right? In science. Okay? Yeah, so for question 7, it's stop 7. Okay, question 7 stop. Okay, question 8. Okay, one of you asked me what effervescence means in exam. Okay, and yeah, it means physics. Okay, so next time I will answer you that. Okay, so make sure you know effervescence means you don't have to write this word in exam, but you have to know that it means bubbling or fizzing. You can write fizzing or bubbling in exam. Yeah, that's much shorter word for that. And so flame test producing a lion flame. What does it support?
Potassium.
Yeah, it supports that the potassium ion is present. So lilac means K plus present. So when you see an experimental result, it will help you get to a certain conclusion, okay, or something you can deduce, some deduction, okay, or some conclusion. If you see a lilac flame, it must mean that K plus is present. What about in the second test? What does adding acid test for?
A carbon dioxide.
Carbonate. Okay, so the formula of ion, carbonate ion, we have just gone through recently. CO32 minus. So if you like writing long words, you can of course write carbonate, but I like to write formula. So this is carbonate ion. This is potassium ion. Okay. Yeah, I will pick writing the formula any day over writing it. Just not so much shorter, right? So if you get colorless gas bubble, so colorless gas bubble with acid, it helps you get to this conclusion that there is carbonate. What about test number 3? Oh, you have done this. So everyone who has attended the lab must know what silver nitrate test for.
Chloride.
Chloride. If it produces a white precipitate, it must mean there is chloride. The formula of chloride is Cl1 minus. Any idea why it must be 1 minus charge instead of 2 minus and instead of 3 minus? Because where in the periodic table is chloride? Which group? Which group?
7.
Group 7. That's how you know it must be negative 1 charge. It's not a random number you see when you see Cl minus. Why is it not 2 minus? Because it's not group 6. It's not group 5. But you see Cl in here. So it's Cl1 minus. Okay? So put this down. Cl minus is present when you get a white bridge. Oh, I noticed that some of you have spelled precipitate wrong. So spell it correctly. Okay? Yeah, some spell precipitate. Okay, yeah. It's okay. But in the exam, please don't. Okay? So now, what is the answer then for question 8?
D.
D for dog. D for dog. Yeah, that's because we have carbonate, we have chloride. The only answer with both carbonate and chloride is D. Okay, I don't think I need to explain it any further. And for question 9, so question 9 is also a disaster. Okay, what will produce a color change? Okay, which of the following produce a color change? So for part 1, if you answer 1 wrong, you should go to the kitchen more. When you add water to sodium chloride, there shouldn't be any color change, right? Yeah, okay, you just dissolve. Okay, so this is the first thing you eliminate. Then you can cross out A and C. So this is another method that you can use in exam. When you see like these answers here, 1 and 3 and 2 and 3. Because you know statement 1 must be wrong, so you remove this immediately. So A and C is out. You now have a 50-50% chance of getting correct. It's either B or D. You just have to check if statement 3 is correct. You can completely ignore statement 2. Because statement 2 must be correct then after you eliminate statement 1. Yeah, try to learn these techniques, okay? We call it method of elimination. So, is statement 3 correct?
No.
No. Okay, it will just dissolve. And cobalt 2 chloride, write this down. It is a similar compound to another compound which can be used to test for the presence of water. No. What is the other compound? Like cobalt 2 chloride that can be used to test for the presence of water. Let me read it first. Copper 2 cobalt 2 chloride, just like copper 2 sulfate, can be used to test for the presence of water. When you, let me finish this first. When you add water to cobalt 2 chloride and copper 2 sulfate, it will turn from the, what is the word that we use to describe a dry compound?
Anhydrous.
Anhydrous. What about a wet compound? Close enough.
Hydrate.
Hydrated.
Hydrated.
Hydrated. Okay. So when you add water to these two compounds, chemical that color change first. For cobalt 2 chloride, it will turn from blue to pink. Blue to pink. Yeah, so it turns from blue to pink for cobalt chloride. And for copper 2 sulfate, it turns from white to blue. So remember this. They can both be used to test for the presence of water. Okay, so that's for today. Okay, I'll upload the notes of the school class. Yeah. You did it. Okay. We will discuss one more question on the back next time, and then we'll move on to the next one. Okay. Right. So.
Oh, chemistry's fun.
What's up, guys? Today I failed chemistry test. And action. Hi guys. Hi video. Welcome to my guys. Hey gang. Gibran bhai.
Computer teacher? You're looking for that?
就收到
喺外圍啊，喺 mailbox 外圍啊，即係你個 mailbox。誒係咯，呢個咯，中四下低呢個。
呢個。
係啊，
哦，因為我就係睇咗呢個入邊。
我前後發咗2次信息俾你㗎嘛，係2嚿嘢嚟㗎。
呢個係另一個嚟嘅。
係啊係啊，我自己嘅補課啊呢個。唔該你啊。
有冇其他方法？你唔係話真係，我頭先諗到我哋呢個唔係第一個，唔係話唔得，我不如俾條 link 佢啦。係咯，佢得唔得？佢就地方冇啊，佢一定講佢諗嘅地方佢一個班人係。你截圖我哋見到條 link 喎。我話得截圖，我可以將佢整成 PDF 嘛，都好似佢哋我哋俾嗰個樣差唔多。總之打我唔到啦，係咪啊？但係。唔好搞啦！唔好搞啦！唔好搞啦！唔好為咗呢樣嘢搞，就算要 test 圖，你唔知點我係唔好為咗呢件事。我同佢講，我發現都係想，佢話準備定啊，佢驚佢就。Yeah, I know. Okay, so everyone, please return to the seat. Right, let me set this up and